This seemingly ordinary shoelace has a hidden world of mechanical devices and machines working tirelessly behind the scenes. A shoelace may seem like a simple, mundane thing, but it's actually a complex system of interlocking components that require precision engineering to function properly. When you tie your shoelace, you're not just creating a simple knot. You're engaging an intricate mechanism that involves friction, tension, and geometry. Imagine a tiny machine that consists of a series of loops, strings, and knots working together to create a secure, comfortable fit for your foot. The mechanism of a shoelace is surprisingly similar to that of a pulley system, where the effort applied to one point is transferred to another point through a mechanical advantage. But that's not the strangest part. The tension in a shoelace is actually a result of the interplay between the lace's elasticity and the friction between the lace and the shoe. When you pull on the lace, you're not just tightening it. You're creating a complex dance between the lace's molecules and the shoe's material properties. And then something unexpected happens. The lace begins to wear down, and the tension changes, requiring you to retighten it to maintain the desired fit. But that's not the only challenge facing a shoelace. It must also withstand the rigors of daily wear and tear, including stretching, bending, and twisting. To achieve this, shoelaces are made from materials that are both strong and flexible, such as nylon or polyester. In fact, the materials used in shoelaces are so advanced that they can withstand the equivalent of 1 billion nuclear bomb explosions without breaking. But how does it all work together? Let's take a closer look at the mechanism behind a shoelace and uncover the secrets of this humble, yet fascinating, device. One of the key components of a shoelace is the eaglet, the small plastic or metal tip that prevents the lace from fraying and coming apart. The eaglet works by creating a small amount of friction between the lace and the shoe, which helps to keep the lace in place and prevent it from slipping. It's like a tiny, invisible hand holding the lace in place, making sure it doesn't come undone even when you're running or jumping. Another critical component of a shoelace is the knot itself, which is made up of a series of loops and twists that create a secure, yet adjustable, fit. When you tie a shoelace, you're actually creating a complex mathematical equation that involves geometry, topology, and physics. But that's not all. The knot also plays a crucial role in distributing the tension along the lace, ensuring that it doesn't put too much stress on any one point. And then something unexpected happens. The knot begins to come undone, requiring you to ready it to maintain the desired fit. This phenomenon occurs when the tension in the lace changes, causing the knot to relax and come apart. But don't worry, it's not the end of the world. Simply ready the knot and you'll be good to go. In fact, the process of retying a shoelace is so ingrained in our culture that it's become second nature to us. We take it for granted. But the mechanism of a shoelace is actually a remarkable example of human ingenuity and problem solving. After all, who would have thought that something as simple as a shoelace could involve such complex mechanisms and principles? But the story of the shoelace doesn't end there. Its mechanism is also influenced by the materials used to make it, such as the type of thread or yarn. The materials used in shoelaces are carefully selected to balance strength, flexibility, and durability, making them suitable for a wide range of applications. In fact, the materials used in shoelaces are so advanced that they can withstand the equivalent of 1 billion nuclear bomb explosions without breaking. But how does it all work together? Let's take a closer look at the materials used in shoelaces and uncover the secrets of this humble, yet fascinating, device. For centuries, shoelaces have been an essential part of human attire, providing a secure, comfortable fit for our feet. And yet, despite their ubiquity, shoelaces remain a mystery to many of us, their mechanism hidden beneath the surface. But that's all about to change in this video. We'll take a deep dive into the world of shoelaces and uncover the secrets behind their mechanism. From the materials used to make them to the complex mechanisms involved, we'll explore it all and leave you with a newfound appreciation for this humble, yet fascinating, device. So, if you're ready to learn more about the world of shoelaces, Subscribe for more incredible stories like this, and let's get started. Want more mind-blowing facts about the world of shoelaces? Hit subscribe and join our journey of discovery. Want to learn more about the world of mechanical devices and machines? Subscribe for more incredible stories like this and join our community of curious learners.